Okay, now we've seen that carbon dioxide and other gases like methane block infrared radiation going out, and therefore if you have more of them you'd expect the Earth to get hotter. But is the amount of carbon dioxide in the atmosphere really increasing? And if so, why? Well, burning fossil fuels definitely releases carbon dioxide, no question. The way you get heat from burning them is because the carbon in the fossil fuel combines with oxygen in the air and produces carbon dioxide. And roughly speaking, if you burn coal, 1 kilogram of carbon dioxide is released for every kilowatt hour of heat you get out from coal. For oil, it's about 0.8, a bit less, and gas is about twice as efficient. You only need to produce half a kilogram of CO2 per kilowatt hour you get. But nonetheless, the chemistry is unambiguous. Burning fossil fuels releases CO2. And how is the fossil fuel amount changing? I mean, for a long time people assumed that humans were tiny little specks on the surface of a huge planet. What difference could they make? And for most of history that's probably about correct. Here is a graph of the world's population over the last 12,000 years, and you can see it was very small, very small, very small, very small, and then whoa! Just in the last very little time the world's population has increased exponentially by a huge amount. This is why it's a problem. If you'd said at almost any point in the last 12,000 years, humans can't affect the world, we're far too small, our puny industries and behaviour can't make any difference, and that would have been true. But now, look at that incredible increase in human population. There are just more people. So here are estimates of the world's population since 1950 up to the present day with projections for the future. So when I was born in 1966, the world's population was a bit over 3 billion, and it's now nearly 8 billion, so it's considerably more than doubled just in my lifetime. And it will continue going up. The birth rate is coming down, but there are still lots of young people, and so the population, depending on your estimate, will probably peak somewhere about 2080 and then hopefully start to stabilise or come down a bit. But that's the big effect. There are just far, 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 far more humans on Earth than there have ever been before. And it's worse than that, because the amount of carbon dioxide being produced per person has gone up. So not only do you have more people, but those people are richer and they're burning more fossil fuels. So here is the per person, per capita carbon dioxide emission going from 1750 through to the present. And you can see that back in the year 1800 or 1850, the average person on Earth burnt very few fossil fuels. They might have burnt some wood, but of course the wood, when it grew, absorbed the fossil fuels. There was very little coal and oil or gas being burnt. But with the Industrial Revolution that changed, and boy did it change, and the amount, so by about 1900 the average person on Earth was producing a ton of carbon dioxide each year. That of course meant that people in the industrialised countries like Britain or the United States were producing far more than that, and most of the world was producing far less. Stagnated a bit due to the world wars and the Great Depression, took off again in the 1950s and 60s, and is now maybe not growing so fast, but it's still vastly more than it was in the past. So we've got a double whammy, two effects. First of all, we have more people on Earth, and secondly, they're producing more CO2 each because they're getting richer, and so the combined effect is a dramatic increase in annual carbon dioxide emissions because of both these effects. Where are they coming from? Well, here's a breakdown by country. You can see that to begin with it was mostly the United States and Europe. But since the 1970s onwards, Asia, first of all Asia, Korea, Japan, and now China have now taken over, and increasingly other countries are starting to come up, whereas in fact the amount the United States, Europe producing is going down. So if you look at emissions, this is in 2017, but it's similar today, you can see that over half comes from Asia, with China the world's biggest CO2 emitter, India also quite a bit, and Japan, Iran, Saudi Arabia. Then North America, pretty big, United States, Europe, quite big, and then you get Africa, South America, Australia's this purple block over here, and this grey block is international flights and shipping, which don't count against any particular country, but they're still real emissions. So, huge amounts of CO2 are being emitted, but is it actually staying in the atmosphere? It turns out that less than half of it stays in the atmosphere. Huge amounts of it are absorbed by the oceans, but you can measure how much is staying in the atmosphere. We'll talk a bit more about this later, but this is the atmospheric concentration, CO2 in mole fraction part per million in the atmosphere. And it has an annual cycle. It goes up and down because the northern hemisphere has more land than the south, and so when it's spring and summer in the northern hemisphere, the plants grow and absorb carbon dioxide, and it dies off and is released in winter, and that's a bigger effect in the southern hemisphere because there's more land there. So that gives you this red oscillation. But nonetheless, the trend is clearly upwards. In 1960 it was about 320 parts per million, and now it's about 420 parts per million and continuing to climb. So yes, CO2 does block outgoing radiation in a rather complicated way, and yes, we're emitting more and more and more CO2, and the amounts of CO2 in the atmosphere are getting larger and larger.